कैमरा नहीं चाहिए ना?
हाँ, कैमरा नहीं चाहिए.
Good evening, everyone. It's a pleasure to have with us our esteemed dignitaries, faculty members, and students with us for today's Tech Talk. Our Tech Talk series is a platform for exploring emerging technologies and their industrial applications. It's where experts and academicians come together to share insights that inspire the next generation of innovators. We are honored to have with us Mr. Biswajit Biswas, Chief Data Scientist at TATA Elxsi. A leader in AI and data science, Mr. Biswas has played a key role in transforming industries with advanced AI technologies. Today, Mr. Biswas will speak on AI, Gen AI in action, revolutionizing industries. He will discuss how generative AI is driving innovation, efficiency, and transformation across sectors. The limitless potential of Gen AI will be explored with examples of its current impact on industries. Before we begin, let's take a moment to thank Mr. Biswas for his contribution to this Tech Talk series. I request the faculty convener, Dr. Pankaj Kalita, to please felicitate Mr. Biswas. Thank you, sir, for joining us today. We look forward to your insights. Now, without further ado, please join me in welcoming Mr. Biswajit Biswas to the stage. Let's give him a warm round of applause.
Thank you so much. Thank you, IIT Guwahati, for inviting me for this session, and also I know it is Sunday afternoon, the last phase of the afternoon already. For corporates like us, the holiday is very important. I don't know. I mean, for academics guys also, I think but all of you are here to listen to me. I'm very honored, and I also came last year for another session. And I always feel good whenever I come to IIT Guwahati, especially in this campus. It's very, energizing for me. So coming to this topic today, so I'll talk about the Gen AI in action in the industry. So you all know that generative AI is the talk of the town. This technology is leaps and bounds. It is progressing, and we'll take a quick walk about the state of technology in the next 1 hour of my talk. And agenda for this is following. So after a brief introduction, where I'll introduce the topic itself, what is Gen AI, how it all came about, and we'll a little bit talk about the technology stack, the different architectures, how the cognitive architecture is changing. Then we'll quickly go through some of the real life examples of implementations of the same in the industry, and specifically, and there are many industries, but I have worked on and very closely working on with some of these industries in manufacturing, healthcare, media and entertainment, and sustainability. So I'll talk about these few examples, and I'll show you some live examples of that. And then finally, I'll conclude with the industry outlook summary, how it is going to be, how it has been last year, this year, and if I extrapolate that to 25 to 30, year 2030, how it is going to be. So you'll get to see that. Hope it will make some sense to you guys. So first is whenever we talk about the generative AI or even large scale AI, the foundation models are very important thing. Now, foundation models is a paradigm shift. So you all have started, or whoever is working on the AI and machine learning, we always start with a small AI model with a small set of data. You have your own Python notebook where you start experimenting with your data, do a basic data analysis, download some of the Python packages and start. So these are all within your environment. They are all small scale custom models which is very specific to your particular data and your particular problem statement. But when you are doing it at scale, then the whole thing changes, and that is where what are the foundation models where the data is collected all over the place in the internet. I mean, the entire Wikipedia, the entire data what Google chants every day, or the entire Reddit, or the journals. All I mean, the previous session we talked about research papers, how to write. So all these, thousands and millions of papers and writings, everything is available for using to build a model, and from there we have got all these BART, DALI, and etc. models. Now, foundation models can be very domain specific. Maybe it is a text oriented foundation model or image oriented foundation model, medical domain oriented foundation. So foundation model, as the name suggests, it's a foundation. Everything else is built on top of it. So and there are even robot foundation models, RFMs we talk about. So each domain is coming out with their own foundation models. So whenever we work with a particular domain, whether it is a healthcare or a manufacturing industry or anything, so every domain is going to have or already having a set of foundation models. So that's your first building block. So and how it does, how it works is basically you put all these data in one place, and typically these foundation models cannot be built in your or the typical infrastructure we have in the industry or even in corporate like us, because these needs hundreds of GPUs are connected in the backplane, which is doing a terabyte data transfer per second. So the cost of deploying that hardware itself is several $1 million. Even the power it consumes every day, you need a mini captive power plant which has to dedicatedly allocated for those computers. So it's a massive thing. It cannot be done so easily. So foundation models are typically done in the data center, and that's why only those big techs, or what do you call it, these MA companies. Nowadays, what is MA companies, Microsoft, Apple. So earlier it was called FANG, now it is called Microsoft, Apple, Meta, all that. So it's called MA companies. So anyway, so these companies can afford because they have those infrastructure, they have the money, they have the things, and so building a foundation model is not the current scope unless you are really have that much of resource and fund to do that. But given the foundation model, everything else starts. So that's where you have these the source of truth, which is from Wikipedia, Reddit, all sort of websites in the world, and then you have this transformer model. So actually the whole thing started with the transformer, and many of you know the transformer models because that is it's a very different way of how the neural networks are designed. You have different types of neural networks. There are actually 32 fundamental types of neural networks. Starting from the simple multi-layer or single-layer multi-layer perceptrons to the RBMs or Boltzmann machines to the CNNs to LSTMs, and then you multiply many layers, add certain classification and other classic layers, and many other statistical methods together, it becomes a transformer model. And this transformer model is just one simple building block. And today the LLMs are done. There are several hundred such transformer models running into that. So that's the scale we are talking about. And then it started, as you know, in 2022 end, December. The entire year was, then 2023, we all had all these models coming out from the houses of OpenAI, Microsoft, Meta. Today, Meta is, every other month they're producing one of the other models. Google is producing Gemini, etc. So all that. So where it is going? So the expectations are very high. The human level of performance is expected earlier, like before the LLM was introduced, it was an understanding that computers will never be able to be at par with the human level of intelligence. But today, people are seeing that dream is not that far. It is just under 40 years. It is possible. They are completely autonomous system. I'll talk about that. What are the different levels of AI? And it is possible within 40 years. And actually, this is shrinking every year. 40 years becomes 35, 30, etc. And by 2025, which is just a few months away, 40% of engineering work will be done by Gen AI. So but we'll see some of the detailed charts later. However, the way the current neural networks are designed, there is one fundamental fault. The fault is it is unidirectional. So there is a set of input, and then it goes through a neural network, and it gives a prediction. But human brains or biological neural networks are very different. They are bidirectional. There are multiple parallel types of networks they run. These neural or the biological neural networks work much differently, and there are hardly any linearity in those models. So there is quite a so there is no interaction or intervention possible in the current types of artificial neural networks, because once the data is given, it has a fixed pattern, it has a fixed analytics, it has a fixed set of architecture. It will only process those using the given weights which are hardwired or coded. You can't do anything intervention. So intervention is possible. Now there are other types of neural networks coming which are called liquid. I am sure you would have heard the name LNNs or liquid neural networks. So liquid neural networks are basically very different types of neural networks, where you will be able to, so these kind of hardware graphs are not there, the weight metrics are not defined, weight metrics are actually generated at runtime. So those are different methods, and plus instead of using a linear equations inside, typically the current neural networks still use linear equations, but you're using a differential equations inside. So there is a lot of dynamic variability is brought into those newer type of networks, but current state of the art is this. So there are 5 levels of AI. Let's look at that quickly. So this is primarily based on how the neural networks can be interactive or make it interactable. So conversational AI is one, which is called level 1. So where it is just you ask a query and it gives a response. So it is very passive way of communicating with the network. The second, little more upgraded, is the reasoning AI, where AI can give an inference. It also can give a reason why it has given a particular inference. Is it a cat or a dog or whatever? I mean, if it has done a classification, it can tell why it has done. So it can reason it out. Third level is it not only can reason out, it can also take actions. So this is the correct technology or current work is happening, making AI active, which means AI will take a decision. After the decision, it will actually act with the real world, get a feedback and correct itself. So that is the third level of AI. Very slowly we are moving to that, not fully yet. We are still at the level 1 and 2. Level 4 is innovating AI. Innovating AI means these models are not only doing actions, etc., they are also innovating completely and finding a complete new way of solving problems. So, which is a very much like human intelligence. So, never seen environment, never seen conditions it has encountered, and it is able to innovate itself. So that is a level 4, and level 5, of course, is organizational AI, or which is like everything autonomous. There are multiple AI systems talking to each other. There is absolutely zero intervention required in such a system. That is quite far probably. But we are currently at level 2, transitioning to level 3. And all these that's why you hear the terms called large action models or LAMs. So we already had foundation models. We already heard about large language models. In the previous session, we heard many of times that came up large language models. Large language models, just language, nothing else. But large action models are not only language but actions. And as I said, the AI is becoming active, it is able to interact with the environment, so it has a capacity or it has a capability to interact with the real world, and that's why the LAM or large action models. So these are cyber physical systems. So these are some of the famous quotes on the AI with actions. So both Rodney Brooks or Ian LeCun, if you follow them, you will know that they are all great proponents of action models, and AI has to be in action. No real intelligence is possible, or in fact, an intelligence cannot be described which is just observes a system. So current set of AI is what we do. We are just giving a data, asking the model to understand the data, interpret, and then give an inference. That is not AI. They say that AI has to be interactive. AI has to be taking actions. If AIs are just observing, it is not AI. Nothing in the world can be learned with just observing the system. So that's the whole concept or behind this theory. So there's a lot of examples of AI with action. So you'll see some of these gadgets have started coming up. This I think you have seen, or some of these, it has a camera. You can interact with it. It will book your ticket. It will book, the holiday or vacations. So it can actually go to different websites, do all that autonomously without even interventions. There are autonomous cars, there are autonomous manufacturing, test and measurement systems, virtual assistants. So today's virtual assistants not only just interact and give some question answer message, but it also does an action. It books a ticket, it solves a problem, it self-fills a network. So it does all those directly. So that's where things are different than what we have passive assistants you have seen. So this is an example of
This is a pretty cool experience. This is a system called Lingo that is not only driving this car, but it's commentating how it's driving. And you can see here the narrative it's giving is telling us why it's making a decision. Now, we now have this running in the car, and it's a remarkable experience to actually have the AI not only drive you, but tell you how it's driving.
Yeah. So this is very important. So it always tells you. Yeah, so you see these examples today are coming already. You are able to communicate with the car like a human being, and it also why it is taking a decision to take right, left or right, why is it stopping, slowing down. So it is able to give a reasoning. So that is a level 2 AI we talked about. Now coming quickly to the cognitive architecture. So there are again 5 types of cognitive architectures. So especially if it involves LLM, large language models. So there are 5 ways to classify those architectures. So first one is a standard, ChatGPT. All we know that you ask a query, it gives a response, very one way, simple, basic stuff. Number 2 is chain. So where you give a complex query, slightly difficult query, and it can actually break down your query into multiple steps, and then it asks those questions separately, and then gets the answers, summarizes the answers, constructs a final answer, and then gives it back. So that is like we do as a human. I mean, when somebody does not understand, we break it down the problem. So that's the level 2. Level 3, level 1, level 2 happen with a single LLM. Level 3, the same thing with multiple LLMs. Now there are mixture of experts or MOEs. So mixture of experts, what do you do? Each LLM has subject matter experts of various topics. One probably on the medical field, one is the manufacturing field, one could be on law, one could be on legal issues, finance issues. So these experts will be together. So this query, based on the type and the single, if a query is very complex, then it can actually break it down and find out who is the right experts to ask to, and then give those inputs and then get the answers back. So that is a third level of and many of our this is called the router technique of solving LLM problem. And next two are the state machines, which is way different than the first 3. These are all state machine action models. So as I was so much emphasis I was giving on the actions. So these number 4 and 5 are these 2 are where we are adding certain capability to this LLM, not just to respond but also act. So what are those tools? So these tools can be a even simple thing like a web search engine. It can also have a compiler to compile the code, do a debug, like we do a typical things. It can do a form filling is a job. So all of that. So anything we do as a human tool. So all these tools can be a resource to this particular architecture. So these agents, and then we bring in the agents. So this instead of LLMs, so in the earlier architectures, we used to talk to the LLM directly. The programmer used to talk to LLM directly. But here, what you're doing is we are giving the job to an agent. So agent is a small piece of code. It has its very little objective and scope defined. So it knows which LLM to ask. It can actually form its break down the query, and then the agents will take care of working with different tools, get the responses back, and finally submit the complete job. So these are the 5 different topics, or the five different types of architectures. These are all cyclic and all that, linear. These first 3 are linear type, cyclic type. But these are the 2 types of networks we have started using in our problem solving. So now let's take a look of some examples. So I start with the Industry 4.0. So in Industry 4, this is what we call is inferencing on edge with Gen AI. So in the factory or the manufacturing system, you sometimes need a very fast response system. The decision has to be taken on the field in the shop floor itself. So you cannot, there cannot be a situation something has spilled, something has fallen, or somewhere a lot has happened, and then the feedback will go to the LLM, and then it will, and LLMs are very notorious for the latency, performance of these issues. And because of that, you need to have those immediate access to those things. So you need an immediate response. So that's what we call is inferencing on the edge. So you run the LLMs on the device itself. So there are several techniques to do that. So we have a Gen AI stack. We have bespoke AI models, basically the models which you write, and all that. So we combine all of that to solve a problem. So, and we call it a hybrid approach where LLMs are used for understanding the context. As you know, the LLMs are very good in understanding context, overall context understanding and connecting the dots. It is very good in. And then very small fine-tuning problems like detecting the distance between 2 points or finding A versus B very accurately. So wherever the precision is required, you actually go for those hand-coded AI models. So you combine these 2 approach and you see they work much better. So these are some of the things we have implemented in some of the factories. So there are hundreds of cameras which are installed for perimeter safety. So it tracks the vehicle movements, the people's how these construction machineries are moving. In many places in the manufacturing setup, there are the chemical factories, there is certain process has to be completely done, then only the next process has to start. So you have these very critical dependencies from process 1 to process 2. So all of that. So there are dashboards which keeps generating and and these multiple cameras, they do the site monitoring, and finally we use a reporting mechanism or reporting system to summarize the day's incident. So imagine if you, in a normal scenario, what will happen? You will get lots of dashboard, 20-30 different dashboards. We call it a operation center like this, where there are people sitting there and there are giant screens there. There are 50, 70, 70, 80, hundreds of screens there, and so many things happening on the screen. So it is very difficult to understand. In the factory, this is a huge factory I'm talking about. So the chemical plant in Gujarat is about 4,000 acres. So it's like a mega city. So, and it's very difficult. There are so many things. So what we do is we give these screens to generative AI model, and it will summarize the whole screens, these 100 screens, and tell what happened over the day or over the week. So it will summarize this many, this many violation of the lane discipline, this many places people cross the road without the signal, Some places people are not used to cell phones. So it summarizes all this and gives a report which is very handy. So this is one example of it reduces a lot of clutter and solves a very basic problem of people missing the thing. So in fact, people have started saying that earlier we did not even know what's happening. Today we know what is happening, but we don't know what to do with that because there are so many information. It is an information overload. So that's why this third solution now we are able to summarize this. I think the summarization has become a big necessity in industry. Every company, every thing has lots of reports, lots of dashboards, lots of data, lots of analytics. Ultimately, what is needed is an action, and for action, we need to summarize and understand what is happening. So what is happening is what is being enabled by these kind of tools. So that's why the summarizing is a big important thing. Similarly, assembly line inspections. So this is one scooty company based in Bangalore. So typically what happens, like they go with the inspection sheet, they will look at this thing, they will see, oh, this bolt missing, paint scratch, this, that, missing, parts missing, etc. Something they will write, something they will not write. And sometimes somebody will distract and they will miss it completely. So this tool, what it does, so they wear a wireless band, and they are not supposed to write anything because writing is not the best quality in many people. So this guy will keep talking whatever he is watching. So he just wear it and he will say this missing, that missing, this is thing. So he just talks and it's much easier. And finally all this data will go to the server, will summarize, and these are all ID'd with the vehicle, etc. And also the complete assembly line, he'll just go inspect whatever he sees and those gets connected, and then if the data gets stored, it gets summarized again, and then the final report gets generated. So nothing gets missed out in this whole process. So this is another example of how to simplify a regular task, inspection task and things in a more, using the technology and with the availability. Yesterday all these were not there because, understanding these voices in a factory setup with a lot of noise, there are different types of machines running. It's a very noisy environment, dusty environment. People who are inspectors, they are not very good in writing. Even if they write, you can't even make out what they have written because somebody who is the data entry person can't even read out. So lots of issues. So all these issues are resolved just by this kind of, a generative AI kind of a technique. So this is an example. And then this is another example. Of course, this is a LiDAR-based, this is an US one highway. So this is a LiDAR-based traffic control, traffic monitoring system. So it analyzes all the types of vehicles moving at different directions, types of vehicles, cars, etc., bikes, etc. And there are other systems also to detect the kind of license plate numbers, etc. All of this, but it gives an immediate summary of how many vehicles moved at what time, what directions, etc. So the complete traffic flow can be monitored using these real time. So and the best thing is it can classify the types of vehicles very fast. And these are there are multiple models, etc., which is running, and it's in real time. I mean, there is no scope of missing it even a second data. So these are some of the perception systems designed using, and you can create a virtual zone and make sure this area, how many crossed. I'm interested only in this particular lane. Lane by lane analysis you can do using this. So these are all products already running in the market with all this. This is an interesting motor current signature analysis. These are for traction motors. In fact, this work happened in collaboration with IIT Guwahati. So there is a professor we are working with, so his students and our guys work together. We signed an MOU last year, and this work is still going on, and it has come to a shape now. So only by analyzing the motor signature, we are able to tell different types of defects, stator issues, rotor issues, bearing faults, shaft faults, etc. So this was with our electrical department. So this is a work, and the first implementation has happened in with a tractor company. So this company is making electrical tractors. So for the tilling the land. So those kind of places we are using it. So this is some example of counting of objects. So in warehouse, it is very important to understand the quantify the number of things, like how many items at every point, tracking, and if or any other spillover or anything issues, etc. You can do all of that using some of these things. Action generation for robots. So today, robot programming takes very less time. You do not need to do any complex programming, etc. You can actually, what you do, you can just tell the command, please pick up this job from that table number A, put it there, and this kind of a complex instructions you can give. The code will be generated internally, what we call is a behavior tree with all possible different options, and then it can perform its job. So that's another example. Now let's look at the healthcare. So in healthcare, we have different types of devices. As you know, there are actually 5 different types of healthcare devices: therapeutic device, diagnostic device, monitoring, medical. So all of these devices are getting AI enabled, and these AIs are actually has to run in the device itself. And many places, the scope of software change is very limited. As you know, in the medical industry, anything you touch, it goes through several cycles of validation, several cycles of regulatory compliance, and etc. So the amount of hardware changes you bring in has to be minimal. So you have to make it almost without changing much of the scope within the internals. You have to write a software which will minimally, impact the overall design of the system. So these things, and So one more thing, I think morning also we talked in one of the sessions. Someone talked that there is a great scope of combining data from everywhere. So a person in his lifetime or her lifetime will go through several tests, several hospital visits, different types of records, signals, graphs, and you can move from place to place to whichever hospital. So, but the data can be combined, and all these is available as your digital persona, so that later on doctors can use it through chatbots, co-pilots, or decision support systems. So, and I'll skip some of these because these are some of the tools, names, and etc., which are to be used in, and then it is becoming personalized and predictive. So the medicine or the healthcare is the boom is happening in the healthcare is because people are asking personalized and precise medicine. So and as you know, this generation is all like your recommendation is personalized, everything is personalized. So why not the healthcare also? Your dosage, nutrition is getting personalized, assisted diagnostics, organ in labs, drug discovery you talked about, and all that. So these are some examples of how we have enabled AI in a hardware where we can automatically scan these kind of scan these plates of petri films and give a quick counts. These things are very common nowadays. That's why your lab test reports comes very fast. I mean, it doesn't take much time. And then we have these telehealth platforms
by creating a digital front door to essential healthcare services at your hospital. T-Engage provides one central location for care teams and patients to communicate. Care delivery.
So it's basically a platform where you engage with customers and things, and Tata 1mg many of you use. So in the back-end systems, a lot of these are being used. So how the regulatory landscape, since AI is rapidly getting implemented in healthcare, so we have certain regulatory things to be taken care. Still evolving because it is very stringent in case of healthcare systems. The option is only physician in loop, so no decisions can be given by the AI system. It has to be vetted by the physicians. Transparency, how the data is stored, data is used for inference has to be very effectively done. Then each category needs a separate set of process like clinical decision support systems, digital twins, CDX, companion diagnostics. So this companion diagnostic is one new way of giving healthcare. So where a small device will be given, this device will be owned by the person for collecting the metabolic other data, and this data will be used to personalize and give a medicine. So doctor will not first time give you the medicine. They will put you on a CD device. The CD device will carry with your body. It will collect data for 24 hours, 36 hours. After that, data automatically gets synced up with the server. You will get diagnosed with doctor. Of course, doctor will give you, and then you will get some. So that's how these things are going to work. So. And also even like a chief medical officer, there will be chief AI officer, etc., which has to be done. Media and entertainment, similar stories, a lot of work on recommendation engines you have heard, summarization, creating highlights. Social media, this is a very well understood area. You immediately any match happens, you immediately see somebody has sent a Facebook link or it is coming up in the Facebook. So these are all automatically generated at scale. So we are working on those technologies, highlights generations. Ad segment is getting totally changed by the AI. The ad you see in your device based on what type of device, is it a mobile phone or it is your large TV, smart TV at your home, or it is an iPad or a tab. So depending on the type of device you see the content. And there is a great deal of research and things happening on how to make these ads very personalized. So one is this VPP is one idea, the virtual product placement. So it finds a place where the ad can be placed, and then it puts that in that place. There are some examples I'll show. This is called Future of TV. Yeah, so these are examples of how things are, changing, and the ad you see in your device. If you like Nike shoes, the Nike shoe will come in your phone, but your friend has liked something else, so that's how it is going to be personalized. So it won't be the same thing. Digital twin is another area. So there is also, so this is basically creating a digital system entirely as the things are. So when you build a physical system, you also create a digital system. So these digital systems are actually so you build a complete digital replica of the systems, and for every subsystem you create AI models. These AI models interact with the real world, gather the data, create the model, build a predictive system. So as if the real system will behave, it will exactly behave the same way in a thing, and it is helpful for multiple reasons. You can actually predict its behavior after some time, how it will happen, if certain things is introduced, how it will react, and what is its operation cycle, etc. So some of these things can be actually very easily tracked based on these. And one of the area we have very effectively implemented is the digital twin for EV batteries. Now let me tell you, these EV batteries are very important things for vehicles, whether it is a car, especially cars, where there are thousands of cells. And managing the cells internally in a vehicle is very important. You hear a lot of incidences of fire and other things happening. So it's a very essential that we have a very correct or appropriate technology which is able to replicate what's happening in an electric building. So many times it happens because there are cell imbalance and there are other electrical failures which is not picked up rightly. The system can really fail. So we need a very effective digital system. So this is what we have done. I'll just play the.
Power and a major driving force in overall cost of an electric vehicle. Battery Management System, BMS, is an electronic device which is responsible for advanced monitoring and management of a battery pack. The computational requirements for running algorithms to meet objectives of BMS is high. In addition, many algorithms depend on a couple of internal parameters of battery which are not directly measurable using sensors. So, digital twin of a battery is proposed to run these algorithms and expand overall objectives of BMS. Battery digital twin is obtained by coupling the real battery data with a virtual model. An accurate and real-time connection is established between onboard and virtual battery. It is an integrated multi-physics, multi-scale, probabilistic simulation of onboard battery. Battery digital twin replicates real-life physical state of onboard battery. It has dynamic connection which is updated real-time throughout the life cycle of a battery. Battery digital twin consists of a developed battery is the
So yeah, you saw that. I think as you know how important it is because battery cost of a car is 80% of the cost of the car. So that's how it is. So other examples of VRs are safety training. So especially on high tension systems. So people are trained on, or we create a digital replica of that and we train the people on those. And it is there for even for very difficult scenarios or hazardous areas where somebody has to be trained very well because any small mistake can be very life-threatening or fatal. So those kind of scenarios, repairing, overhauling, maintenance, you need to have a very exact digital replica which has to be created so that people can actually get a almost lifelike experience before getting into the real system. And not only those systems, but also a metaverse for automotive sector. So you can actually get a feel of a car without having in a car. So many of our, we are planning showrooms of things where because that model has not yet come or arrived, but you want customers to feel how it will be the next area. So you can actually make believe see it, you can see it in a system and where we are set and it will create all the simulations, sensors, simulations, so that you can actually feel how the thing going to be. So we have done, we are working on all those, very realistic metaverse systems, and there is a lot of AI here because without AI, it won't be as, replicable as it is going to be in the real world. So I'll play a small video clip just to show the types of works. I have to skip it because it's a bit longer, so you can. This is actually a VR video, but imagine you are wearing a VR and seeing it. This was done for a metro rail. You get an idea how is it? Sustainability, I think there are a couple of examples of that. So one is this PFAS, microplastics. So PFAS or microplastics are, there is a lot of talk now happening on these areas. So especially in medical area, it is very important because in the medical field, a lot of implants, prosthetics, or sample collection devices, suction devices, especially an operation happens, they use these tubes, internal organs, very inside the body, to suck out the blood and other fluids. So a lot of plastics there. IV solutions, people who are given intravenous drips, etc., and also all through different plastics, and guide wires, people who are go through angioplasty and other things. And so there are various ways, all these, different things that your plastic is touching very internals of your body parts. And these microplastics or PFAS are very toxic. And PFAS comes from various different sources. I mean, it can be from water, pollutions, from other sources already there. So, but in the medical arena, it has become a mandatory now that any plastic materials and anything you use or any of these things, it has to have a PFAS compliance. Now, what work we have done here is, like for example, a certain procedure is going to happen on some patient's body. What is the total process? Step A, B, C, D. So we have built an AI, and then what is the permissible limit defined for such a process? How much of microplastics can be affordable by the human body? So if you break down the whole process from A to whatever steps, then from each steps, what are the instruments being used and what are the different plastic components being used. So you go to their reference websites, the manufacturer websites, collect the data and summarize and calculate what is the summary. Now, if that threshold is reaching, the amount of plastics it is you are injecting your body is more, then it will suggest recommended options. Use that manufacturer here, etc. So it will give you 2-3 different options to lower the entire picture. So these are the types of works are happening in terms of reducing the risk of this microplastic getting inserted into the body. And so this is one very important, and customers are now looking for it. And generative AI and AI is very essential because it's basically an optimization problem, as you know, that there is a threshold given, there are options given. So find out which option has the least possible option. So that's a mathematical problem. And then another work is AI-powered monitoring of water bodies. So this is a company which produces the world's best coffee. So if you go to anywhere, I will not name the brand. So this company produces so much of coffee that, as you know, that when coffee is the ground, after the process, they have to throw that. But you can only throw this much, and those things come to the water body, and then rain happens on the dump, and then the entire thing goes carried to the water and the river color changes overnight. People complain. So the government has come out with a regulation that this has to be regulated. So what we do is we have put a lot of cameras in those different points, and then that will also take the weather, the probability of rain, and other various informations. And then it will monitor the level of the clarity of the water and what are other weather parameters, and then it will, because of your tide and other things, so where the accumulation will not stay and it will first flow. So it will tell you those windows of opportunities where you can actually dump, and then it will get cleared faster, and it will not contaminate much, and it will not be. I mean, it has much more, a much better way instead of unknowingly dumping and making it more, costly. So this is another example. So these are two examples, and few more are there on carbon footprints, etc. But I think for today I'll leave it here. So now, summary. So if you look at the opportunity of where the AIs are, so these are the four areas the AI is trying to operate. Production, services, front office, back office, core capabilities, R&D, supply chain, etc. So these are the different types of areas AI is, and what we call is the everyday AI and game-changing AI, and external customer-facing, internal operations. So where corporates or companies are spending money. Obviously, game-changing AI you cannot get a game-changing AI every day. So most of it is the everyday AI, and that too things which are internal operations or external customer facing. Now, external customer facing, if it gives you an ROI or improvement in your price points, then only you'll be able to do that. So this is how we see the whole ecosystem is, and the types of work happenings are in customer self-service, avatars, chatbots. This is one type of work. Then you have workforce training, material efficiency, industrial equipment longevity. So that is the core capability R&D area. So these are the two areas. Some spend is happening, and if you look at, okay, this is a different. I don't have that chart. Okay, I don't know if you can see this graph. So this is the famous hype cycle, Gartner hype cycle. Have you heard? So that is like any new technology or a product, they go through this first, that is height of expectation. It goes very high, top of the hype, and then people say, oh, this is called trough of disillusionment, where people get crestfallen. Then people realize, okay, this is called the phase of enlightenment. But you accept the fact of life and say, yes, fine, this is how it is. So AI is currently somewhere here, and I think generative AI is already started. So that's what they're trying to say. They're in this part of the hype cycle. So they're going through some kind of regulations. And if you look at what are the big techs are doing, Amazon, Microsoft, Nvidia, and what are the different startups they have created, and through these startups where they are spending money. So they're, as I said, they're building a lot of agentic capabilities for actions, driving efficiency of AI, and all that. And one good thing is from last year to this year, the spend has increased by 25%. So which is basically a good sign that there is still some research happening. Now, this is my summary of overall industry, how it is. So what are the high impact areas? Things are, so one is requirements, design, software, engineering support, testing, documentation. So these are the areas generative AI is doing very good. Like people are using in IT industry for writing softwares, doing design, and when a requirement is given, requirement to converting to the design to the code. So that's path be getting streamlined. So there is a lot of, and especially on the testing, documentation, a lot of effort is being spent, and it is giving a lot of benefits as well. So today, many of our engineers do not write any design documents, because you almost get 60-70% ready documents which is ready to use, and 30% you have to do yourself. So that has been the case. So very little of the traditional cycle of coding, design, etc. Testing also, test case writing, not many people are doing. Test case writing is totally by AI. So the moment you write a piece of code, you get 20 different test cases immediately. So that's the level of thing. So software industry, that's why you see certain people are some companies reducing number of people, etc. Is because the testing side is getting automated quite a lot. So design little less, coding little less, but the testing cycle, testing and documentation is completely by AI. So there is a lot of impact in those two particular areas. So Copilot for skill. So another area is develop Copilot. So people are developing Copilot for everything. Copilot for code, Copilot for writing a document or an article, Copilot for testing. So everywhere Copilot is, so especially where the skill is required. So initially we see 40 to 60% of the productivity gain for POC and pilot stages. So whenever we do it, so there is a high gain, but it drops when it's attempted at scale. So that's where I think there is a little, some scope of improvement here, and human in loop is going to stay. So even though there is a lot of technology intervention here, but human loop is going to stay because heterogeneity of the work, high variability of workforce, take limitations are still there. So because of that, it is not the most completely autonomous human. Without human is still not possible. So going forward, if you summarize this, 2023 was the year of exploration. People got surprised, wowed with this technology. What is this ChatGPT thing? People call it now ChatGPT moment. So, and people all took note of it, education, inspiration, and all that. 2024, lots of money was spent in building POCs, and some of the POCs really gave very good results. Some of them, or many of them, did not give good results. So overall, it is a balanced. It is neither. So we keep saying there are 4 quadrants or 4 different areas when you apply AI. There is one quadrant, you get that wow factor, like, oh my God, I never knew this is possible. Second layer or second quadrant, which is, yeah, it is okay, but it is good. It is good. It is not great, but it is good. Third quadrant could have been better, 50, 60, 70%, 60% okay. The last quadrant, or the last 25%, is actually horrible. Whatever it produces is totally wrong, hallucination is very high, the code is writing a crap, the design is unusable, or anything. Even the co-pilot gives answer is absolutely wrong. So this 25% problem is going to be there for long. So you may have first 50% usable, middle 25%, little effort, lot of your what you call is this reflection of the systems and debugging methods, etc. You can still solve it. For the last 25% will be your killer. That will kill your service, and that's the reason many of the companies, they have done POCs, they have done many implementations, but going in a big bang everywhere, replace everybody and everything autonomous is still not going to be there for some time. So that's where this is that 2024 is that. Now 2025 is going to be more cautious approach, and a lot of focus will be building the robust frameworks. That's why I talked about the agentic workflow. So that is giving promise, but still early days of it. Large action models, etc. I talked about. So those are some of the good initiatives. Robust frameworks. The focus is on tools. So anyway, so I did not in this session I did not talk about the large action model because I presented this in IISc last 2 weeks back, exactly on that topic, how large action model is going to change the AI. So anyway, that's a pretty large relative deep or involved subject. So, but that is one which is coming up. So that's where frameworks, etc. Focus on tools, validation techniques, ROI, and cloud cost. So one thing I did not mention is, so all of these cloud-based systems are very costly. So many of these, if you use 24 hours, a LLM system on a large GPU, 24 hours, it takes about $10 to $12 per hour. So say if you're running 10 hours at least, 8 hours, 10 hours, $1,800. Pretty costly. So no service which is cost sensitive can run on this kind of cost. So this is one challenge, cloud cost. So it has to, you have to have a solution for that. You have to host it in your local server, your local machines, and all that. So those are some challenges. Now I'll probably take questions after just I conclude. Now these are the three areas: data generation, synthetic data. So if you see this graph, if you see today's AI is working or struggling with very less amount of data, but the kind of improvement we are looking at from AI is not possible with the current data we have. So we have to have a very robust, strong method for generating synthetic data. Without solving the synthetic data problem, you will not be able to go much on the AI. So this is one prediction, like there will be a lot of focus on data generation, because to some extent, yes, it is true that AI is getting failed by the data. the kind of data people generate, the kind of way people interpret data, process data, store data, it is pretty haphazard yet. It is still not the right shape, etc. And any field we take, the first problem we hit, or first bottleneck we hit is there is no data. There is no right data. Data is there, there is no right data. So unless you solve this data problem, it is going to be a painful area. So that's why there is a focus on data generation, synthetic data generation tools. So there will be a lot will be talked in the next few years on this topic. And we are definitely making a migration from LLM to LMM, or large multimodal model, to LAM, or large action model. So that the action, again, the action I am reinforcing. And finally, of course, the autonomous agents. These agents is going to be very autonomous, and any future software complex architecture will have hundreds of agents. Each agent will work with many different tools, and most of your coding or examples will be working with these agents. So agent is the future. So that's what the topic. So these are three takeaways from like what we are observing this field, or what we are observing in this entire AI or generative AI field. So mixed results, good results. There are very not so good results, but finally there is a steady progress happening, and that is towards these 3 points. So with that, I'll probably take some questions and then we'll conclude. Yes. Yeah.
So I have two questions. First is how generative AI is special over AI, and second is what is exactly Copilot?
Okay. So generative AI, as the name suggests, there is something getting generated, right? So generative AI are those where there is an input. So it is not just inferencing. So normal AI is primarily for inferencing like you have started input, you want to infer, like is it this? So it could be a classification kind of inference, it could be a regression kind of inference, it can be any of those. Like typically these are the two main clustering, classification, etc. And the generative AI is where you are generating something new. It could be a new text, it could be a new image, it could be new video. There is something newly getting created. So that if those kind of problem statements or those kind of things we call a generative AI type of. Now next your question is Copilot. Copilot is in a generative world, generative AI world, it's a more loosely it is being used as anything which is assisting you. So assisting you to write a code. So if I have the thing, I can show some example of a Copilot I have in my machine. I don't know. The screen share as a, or maybe. So if you see this button, I don't know if you will not get it in your machine. So this is a Copilot. This is designed by Microsoft, but we can build our own Copilot. So now you can do all this. Help me plan, help me write. So it will read the mail as I open the mail. It will read the mail, and then it will suggest me. Should I reply? You want reply in a very strong way, weak way, this way, that way. So it will give you a lot of suggestions. So and this thing is helping me. It is not that it is not helping me. There are many times I have asked. I have actually made a rule like these kind of mails where I have to say approve. Many of my job is just to say okay, approve. So if this is these things, you just approve. I don't have to do that. So Copilot does that. So Copilot, in a way, is my assistant. And actually, what happens is I think in this session also, this whole Copilot will actually summarize. I talked last 1 hour. It will summarize everything. What all I have talked, what topics I have mentioned, what are the keywords I have mentioned. A complete summary note, as if some assistant has. And it's very useful. And we use it very, very effectively in our meetings. So there are people who are in a meeting. It summarizes the topics discussed, action items discussed, who will do what. Otherwise, we used to do it afterwards. Hey, what do you do? You do this. The whole thing. So that is Copilot. So that is your just to answer your. Yeah. Yeah.
So a slide of synthetic data generation.
So synthetic realization, according to my understanding, means that we are creating new data based on previous data. So who will own that data? Is what my question.
If you are generating, even if it is a synthetic generator, it is your data. It is.
If I'm taking data from sources like Reddit, Wikipedia, and then based on that data, my model is generating synthetic data, then who is the owner of it?
It is you. That's very clear. If because you are generating the data for your purpose, and if it is now how much different is this that I have not seen any problem there because.
Right, sir, because platforms like Reddit, Stack Exchange, and all these places are community owned, and they are pools of resources by different minds, and it is everybody's own data.
Right.
When you are taking everybody's own data, and then
The Reddit and etc. wiki is a little different example. So because there already a content is there, and if you are generating a content, I don't know. I mean, if an example like there is an article on some technical topic, you ask or your synthetic data, you generate another topic which is similar to that topic. I have not seen that kind of use case, but the synthetic data I'm referring to or we are using is especially for the numerical data. So numerical data is much easier to handle because you know that you have these data bands. These are your data distributions. So you actually algorithmically see which distributions are missing. You create those, interpolate those. There are primarily generative. So generative algorithms are very good in doing this kind of numerical data. So it should be able to do that. So that is one. Second is generating images. Now there are many imaging problems where you do not have enough data. There we are generating some images. Third, there are certain types of what do you call, even in the medical imaging and medical records. So there are certain gaps we are able to generate data using some of this synthetic data. But synthetic data generation, one challenge is like you need to know how much your synthetic data versus the real data, because ultimately it's an algorithm which is running. Ultimately, if that data is more than your real data, so ultimately your model will learn the algorithm itself. So it will defeat the purpose. So that balance keeping is very important. Yeah.
Sir, very nice talk. Thank you for that. I want to understand how the business development of Elxsi now. So, an example that you will give in a factory, you are observing all those things. So, while you are offering some solution to client, are the clients know if such kind of solution exists, or do you Tata Elxsi to go through them and suggest the solution? How is the current scenario of you getting a business?
So actually the way we operate is customer do not say you use AI or GenAI or something. They come with a problem statement. Now I showed the example of PFAS, microplastics. So customer did not tell you use generative. Customer tells I need a solution where before an operational procedure takes place, you will help me to decide the kit which has to be used for this so that I don't get into a problem. So that's the problem statement. And then we use AI, then we realize manually if we do this whole process is beyond the time it can take. So summary is customers come with a problem in the respective OS. Even in the battery case, it has to be the digital twin problem or not, so that is our decision. So the selection of technology or technology stack is totally by us. And what we get from customer is a problem statement that is kind of little, as they see or as you see through the thing. And many times it is also through a, mutual discussions and other way. Like they are describing certain problems, but we realize there is so many other things also. So it's more of a discovery of issues as well as we talk and engage. So there are multiple different ways.
So I have a second question, sir. You told that currently the large language models are mostly, driven by some big corporation effort because there are a lot of power needed, money needed. So will it say in case of LAM, will it lead to some monopoly kind of a thing and some need to buy it, right? They need to charge something. How is this model is going to become in 1 or 2 years?
This is going to, as it is for now, I mean, at least for now, this is going to be a big tech monopoly. If you are using the LLMs or if you are so much dependent on LLMs. So, because writing your own LLM is not, ROI is not there. I mean, your return on investment is not going to work out at all. So, the answer is yes, some amount of monopoly is there, and that's why today the options are very limited. In the sense, if it is OpenAI, you have to go with Microsoft. If it is Gemini, you have to go with Google. But fortunately, some of these corporates like Facebook or Meta's policy is very different than Google or Microsoft. Google or Microsoft are charging. They are called closed domain LLMs or closed. You have to pay for the Llama or the Facebook. They are making it completely open source. Their philosophy is you will not be charged for using the model itself. And similarly the Mistral, similarly the Anthropic, I have to check whether it is. So there are few of them who are actually promoting the open source models. And they will build services in such a way that you do not have to be using the model, but other platforms and frameworks you can create an application and you can use it. So those kind of models are coming up where we will be able to kind of circumvent this problem. So to answer or summarize your how we are solving this problem, many of our customers, in fact, record I can. So what we are doing is some of these models we are hosting locally at customers. So what we tell our customer, you buy the hardware, we will take the open source model, customize it for your requirement, put it in the hardware, so that you don't have to go back to Google. So this is one way and this is one. So there are two classes of things. Some customers who are running for the initially with the cloud, and once it proves that it is okay, good to go, they shift it to the local.
Sir, I had come across an article in which they were claiming that AI has surpassed human intelligence, and so to what extent is it true? Like, I mean, as
certain areas and certain very specific cases. So if you look at some of these, they are able to predict that. I mean, the MRI scan image or some of these X-ray images, etc. So, for example, today there are certain models which can actually, from X-ray, they can detect the heart conditions, etc. So, which was very difficult. I mean, typically X-rays are used for just to see if this is normal or abnormal. But what kind of heart condition? That is very difficult. Even the best of the surgeons are still not that. So, in some of these examples, AI has surpassed the human intelligence.
so it has learned it by itself, or the human has given data and guidance, or how is it like? I mean, it has that cross that because humans are not aware of that.
So it is, I think, I would say, that's why there is a definition of intelligence. So there are two types of intelligence. The human intelligence, if we see a cat once, we will know a cat whole life. We don't need thousands of images of a cat to understand. That is, but when you give a millions of data, the information, the way it is organized itself is a different kind of intelligence. So this is called kingdom of so the intelligence definition has changed. What we know as human intelligence may not be the complete definition of intelligence. Human intelligence is intuition and some things and all these are extra, right? Inference, intuition, etc. So whereas machine intelligence, sheer power of information. Information is so highly concentrated in so many different dimensions that itself is an intelligence. So there's a different type of machine. This machine may not have the logic to abstract so well like human. But because they're having so much of information about a certain state, the X-ray image, a human brain or a doctor can remember his best diagnosis 10-15 cases max. But machine can remember million images. So that intelligence versus this intelligence, they are two different intelligence. So some places that works, some places this works. So it's a definition of intelligence which need to be reformatted and re-understood, what to understand again, because sometimes the information, people used to call information is not knowledge, but today, too much information is a knowledge. Yeah.
Right.
I take that.
So there is some drawback of Kerala. Like now people are using, in school people are using for the writing essay. So it's down for the creativity as well.
This
Like for writing a poem.
Hmm.
So if they need competition is going on, people are writing a poem from the ChatGPT. They publish. So
This is now, I mean, you see nowadays songwriting, song composing has become a machine.
Creativity, sir, is it like the debate is there, no? Like whether AI is killing the creativity or the imagination of a noun.
why we are doing so much effort.
Yeah, no, I mean, this is a common concern, the very obvious concern. Song composing, poetry writing, writing itself, writing and all these were supposed to be a human forte of the intelligence, like which machine cannot have. But machine has done it. So, you know that suno.com, that's another website, right? There you can actually compose the music better than a lot of other people. I mean, in fact, nowadays what is happening in any that day I went to a hotel, the music is being composed by the AI, I mean, those kind of things. So, whether it is going to be, some impact will be there on the creativity. Yes, people who are on the creative field, especially on the content writing or some of this brand imaging and these things. So today, I mean, earlier before the GPT and all these daily models, so if you ask a brand designer, give me a logo design, it will take weeks, months to design a logo. And today you give a prompt, give me a logo, 20 different logo comes in 10 seconds. So of course, some of this impact will be there. But I think we have to find a place where human intelligence to be used. So probably the person who is good in brand logo design or songwriting, he or she also has to use the software, take 10 songs and you modify on top of that. So your work of doing the composition from very basic beginning, maybe that will be far better. Say Ardinorman or say, if he has this tool, he had this tool, he could have composed some much better song than he has done it. So it's like taking human capability to a different level. It is not, so that's my problem. And that is what people are saying. It is not threatening your creativity or something. It is augmenting your creativity to reach to the different level. So there is no limit there. Yeah, I'll just. Yeah.
Sir, when it comes to interactive AI, a lot of data is being fed to it and a lot of common interactions happen between many people, right? For example, when I was experimenting with Meta AI, for example, like whenever I start a conversation, in further conversations, it takes references from the previous interactions and I can clearly see that it is storing that data, right? So in such cases, this data redundancy stay as an active problem, and are there good solutions for it? Because many people are using, for example, Meta AI, right? So and it is also storing a lot of data. So like, are there good solutions for the data redundancy that we see?
No, data, see all these models, no? I mean, they are storing your data, what kind of queries. So this was happening not now, even before. When the search engine started, even before Google, what are the search engines before Google? Alta Vista, Netscape, right? They are the early, even they used to store the searches. So, and data, anything you do online, digital, data is there. And that's how the whole Google ecosystem started. In fact, if you see Larry Page, one of the co-founder of Google, he, 10 years back, I read his interview. That time AI was not that popular or something. He said, we are not a search engine company, we are an AI company. He told this 10 years back. Nobody understood what he meant. We all know Google as a search engine company. But why he said 10 years back that we are not a search engine company? We are an AI company. Today we all understand what was his thought process, etc. So all these search engine companies or any of these companies who give a public domain service like this, they are always going to store their data, and this is not a new. So, but with that data, you are also getting a service. So, right, the service like you are getting a recommendation, a page recommendation you are getting, and search is free, right? Google Maps is free. You know, this kind of services has come up because this data is available, because this company has made a lot of money, and then of course advertisement, etc. So it's a give and take. Like if you say that I don't take my data, then you will not get this service. Then things will not improve. So it's a cycle, right? I mean, they will take something, they will give something, and then whole thing will continue. So what I'm saying is it is not new. It has been always there, and it is going to be much more. I mean, that's the main.
So the AI models that we are familiar with, they are computational models.
Yeah.
But sir, as you said earlier, that intelligence is more than computation. It's not just computation. So,
Right.
do you think that AI will evolve beyond computation, or there are some problems which would probably never be solved with the help of AI?
This is a very loaded question. It is really difficult to say where AI or this evolution of computation will stop. So, but still, I think if I have to see 10 years down the line, 30 years down the line, definitely the trajectory is AI is going to be superseding human intelligence. Definitely, 30, 40 years. That's what the prediction said. And it is not just us. Every other research groups or these consulting groups, they are all telling that the human intelligence will be superseded. We will be just a like today we are controlling AI. It will be other way. Like AI will be controlling the human. We will be just the resource, and our inefficiencies. I mean. It will be visible to the eye. I mean, I'll go to a more philosophical level. The way we govern, the way we run our society, the way we select our government, AI will soon clearly see that there is a huge imperfection there. They are the we are not. I mean, there are not the best people, or they are not the this. So all those questions will come. There are, and I mean, I'm not talking of Indian politics, even the global politics. Or the geopolitical scenarios. There's so much of unrest. Like the countries are fighting, there is almost a nuclear Armageddon possible, and this kind of things. And if you follow what is happening, the way anyway, I'll get into those. So this is a very imperfect world, and the way things are running. I mean, so it may happen. I mean, I keep reading those. There will happen that when the governance will be taken over by AI. It is possible. So it is no more. It is not just solving some of these, small this kind of problems. If 30 or 40 years down the line, even there will be there is already a talk called open source government. Open source government is like it's a AI based, like there will be no human head of the state. So the policies will be made by AI. Policies will be governed by AI. We are already in that direction. So,
sir, I was referring to more like questions which cannot be easily solved with the help of computation. For example, there is a issue of ethics. So it is one thing that I don't think it is a computational question. It is a subjective question, like whether a thing is good or bad. The answer could be different for different individuals. So how do you envision AI?
Subjective. Yeah, those are some gray areas. I think there is no right or wrong. In fact. There is always a perspective for everything. So, whereas we want to be in a mathematical world, we want everything to be deterministic, everything to be well defined, and things. So, we don't know. I mean, that is an area probably left to humans. So, what? Okay. Any other? Yes.
Sir, my question is regarding mass personalization of products. So, mass personalization of products. So, we can generate images now. It's very easy. Visual models are there. But how can we bridge that gap from generating an image and doing like printing out additive manufacturing to additive manufacturing
there will be human in loop. I'm not sure that we are there to kind of convert from genetic image to doing a CAD model and then directly to the thing. So, but it's a journey. And 3 years back, if somebody had told me that AI will write a design document from design to write a 60% ready code, I would not have believed. Even I used to be very skeptical. Even 2022 December, when some of these news came that there is writing Copilot, Microsoft Copilot or GitHub Copilot is writing code, I myself went and checked, and I was surprised. How you can write so accurate code? Of course, I am a subscriber of GitHub Copilot. I pay every month 800 rupees to just to check how good they are, and they are really making good, much better every other day. 6 months back, it never used to. I used to write a lot of code, and it's not of it. Today, hardly anything. I gave a multiprocessor programming to be done where there are 10 processes to be done with certain mechanisms and types of things, etc. Otherwise I would have written a code, but I almost wrote like a pseudocode, and you won't believe it gave an 80% code. So it has improved. I mean, 6 months down the line, I see that change already. So things are improving, things are happening, but I still think there will be human in loop in what I have seen not good is like solving a complex problem in a totality. That's still not. Single problem, slice of problem, it is able to solve. So again, for this kind of problem scheme, there is a step by step and but definitely it will go there, and a lot of these things will become kind of automated as much as possible by this. Okay. Yes.
Okay. Shall we conclude?
Thank you so much. Thank you for your time.